In version 23, which stands for the year 2023, of the Packy software, we've introduced the concept of templates. So when you go to train a new detector using Snap and Train, you have the ability to either select from an existing part number that's already set up. For example, if I select the Influx 2, or name a new one. So if I were to use an existing part number, all this is going to do is enhance the training. Whether it be traditional machine vision used to quickly get a detector running, or an AI-based detector. So if I create a new part number, in this case I'm just going to add new to the end of this one, you'll notice that this template option comes up. So it gives you a list of templates to choose from, and you also have this little switch to the right for Express Train. If Express Train is selected, checked, then the program uses traditional machine vision to train the detector, or at least set the detector up. In all cases, the idea here is that no matter the template that you use, the process of setting up a part number is automated. Because we now know how these particular templates should be sequenced, we can just purely automate the entire sequence, get the user set up with a part number that they can use right away, whether it be an AI-based detector, which as we know takes time to train, or an express detector, which is quick to train but far less accurate than AI-based detectors. So because I chose an existing part number, it filled this in as the part's present or not, and it used Express Train, even though I did create a new one. So I'm going to go through the process of how to use that. So as usual, you want to go ahead and select your camera and your camera profile. And then since we're using Express Training, in this case, it's going to start up VBAI so that we can use it to set up our inspection configuration. So this works same way if you're training AI or if you're using Express, in that you take pictures and you label the features or parts that you want to detect. So if I go ahead and snap in this case, actually hit snap, then I'm doing part no part, so it's going to give me the part no part label options, so I just select those. Notice these are black and gray parts, which is fine when we're doing part no part. We don't care about color in this case. So go ahead and take a picture of parts in the nest, and then I'm going to go ahead and remove these. Snap a picture. And I'm going to rename these as no part. So I just select the other state. You'll notice down below the progress went to green, even though I've only done 2 images, because when doing it in Express Training, all the program's looking for is that there is a part and no part state in each position. That's already been defined. So in this case there is. We're all set and ready to go, so we can just go ahead and train at this point. It's going to say for switching or training detectors, you want to verify your labels. So go ahead and hit OK. And now, as with any detector that's being trained for the first time, or really continuously, you just verify that the labels are put down correctly. This is just to catch human error. Yeah, it's definitely no part. And then I'm going to go ahead and save. I've got 0 images left. So if we were using AI and we were using a number of samples to do this, we would go through all of them, make sure that they're all labeled correctly. We would verify that the attributes are set right. So in this case, since we're doing part no part, we're going to call these both expected. And then it's going to ask me to complete one last step. and that is verify that reset the position of the boxes for use in express detection. The reason being that express is going to use either intensity or pixel counting, and the more directly over the part we are, the more accurate it will be. And when you're using the AI-based detectors, that's less important. So if we were training an AI-based detector, we'd skip this step. But notice that the machine is asking for us to train, and what this is doing is training an AI-based detector based on the samples that we've provided, as usual. So we're really doing two things in parallel here. We're setting up a detector that can be used immediately, and we're also training an AI-based detector that we can use in the long term for more accurate results. So I would just do this like I do usually. And I would go ahead and close this out to start the training process. Now I can complete the process of setting up this detector. So as it says, adjust the shown labels to the most noticeable area of the part that determines presence or not. You have a little checkbox here. If you check it, it's going to say that it's going to require you to adjust every single label. But if the boxes are uniform, meaning I just use this in the automated way and it put down the boxes for me, I can just leave that unchecked. And all it's going to really do is just ask me for, because they're uniform, for me to zero in on an area of this part that is always going to be consistent and allows us to do like a quick check there or not there. I'm going to kind of zero in on this center area here. And when done, just hit save. And at that point, you'll notice a progress bar that's going through and determining the best settings for this detector. And then it's going to go ahead and automate the part number creation, sequencing, and off we go. We have a running detector at this point. So that's kind of a quick recap, but I'm going to go over and do a couple more just so you get a sense of differences in the way that this works, and really the fact that there's no difference. Let's start this back up again. So this time let's just create a class. So let's create an object detector in this case. So if I was going to create an object detector, and I select the object detection template, camera as usual, and leave express training off, this is just going to be training a detector called object detector by labeling the objects, just as usual, just as the original snap and train worked. If I do express, same idea, same type of labeling, but it will use traditional machine vision to more quickly get the detector running while we're training an AI-based detector. So same concept, no matter which one you use. There are going to be some nuances of some of these, so like surface defects, for example. If I choose the circular one, I'll need to label it a little bit differently to kind of create a ring. So say I want to do surface defects on an O-ring. I would use a circular, and that's going to work a certain way. We'll make more videos for this. But these all work the same way. They'll all set up an automated sequence so that the operator does not need to do that, the user, and they'll be ready to run. You can always go through the manual process of modifying the configurations or creating configurations, but this speeds up the process by using templates for common things that are done with machine vision. So object detection in this case, and I have it on express, so it's going to go ahead and start up VBAI, the traditional machine vision engine. And then once it's started, I can just label like usual. So now, since I'm setting up an object detector, there's not really going to be any, there's going to be a part present and no part state, but really we can set up our own objects, object names. So let's just snap this. Let's call this empty. Let's keep it. Call this empty as well. And then I'm going to put in a couple different parts this time. So, put in that part. So now I put in some different types of parts. Can, of course, got a live view, so I can adjust these all I want. And go ahead and snap. Now I could switch them over to part, no part, of course. Or I could label these as their own thing. So just edit the label. Do an edit. I'm going to call this part 1 and this one part 2. And we're going to go ahead and switch back over to the live view by just pressing on the screen. Go ahead and switch these parts. Snap picture. Do edit. This is part 2. And this is part 1. Go ahead and save. And then I continue with this process. Since we have an object detector, we're going to require at least 25 images. So we'll go through this entire process as usual until we've reached the 25 images. And then a detector will be created, both AI-based and an express detector, to detect these states that we've set up. So part 1, part 2 are empty. That's all there is to it. The part number itself will be set up automatically so that you have an object detector that when you put parts in front of it, it can determine if it's part 1, part 2, or an empty. So one last thing I want to go over is training a detector that's already been set up again. So I'm going to go ahead and choose the new. So the influx test new, and if I kind of just add a character here, we'll see that it's parts present or not already set up. So let's kind of trick this out. So notice that choice doesn't come up because I'm selecting something that already exists. I'm going to go ahead and do rear. And then it's going to open up the template that I've already set up. I'm going to go ahead and put my original parts back in place. So let's just imagine that the camera moved. So now that we're at a different angle, we'll just run this just like the original process, but this is going to be even easier this time because there's no sequence to set up. It's just purely affecting the parameters of the express configuration and the sequence is already there. So I would snap like usual. Now we'll just label these as part. Save. Now we'll go ahead and remove the parts. Switch to state. Notice the progress goes green. Training button shown. And then I would go ahead and just follow through the process as usual. Now, because this one is already set up, we're not going to have to adjust anything. So we just verify these. Go ahead and verify our attributes, both expected in this case. And then from there, the parameters are updated, the configuration's all set and ready to run, and adjusted for the movement in the camera or the nest in this case.